Hi, I'm Jana. This is an exclusive first look at Andrew Jones's newest speaker, Troubadour. This is the first speaker that Andrew is releasing for his newly formed Los Angeles-based speaker company, Jones and Cerreta, founded with his partners Jamie and Bill Cerreta. In this video, Andrew breaks down Troubadour and tells us a little bit about his design process. Andrew, Jamie, and Bill reached out to me around a year ago to tell me about their new venture, and I've just been super excited for them ever since, and equally excited to be able to share this with you all. I hope you enjoy it.
With the grill on, it becomes a nice looking piece of furniture. I never thought I'd say that about Loudspeaker. This is it, the new Jones and Cerreta loudspeaker. This is the first finished prototype, so let's talk about it. Our initial concept in thinking about what should this loudspeaker be was to look backwards, to look at how we used to listen to music. And we typically used to have big loudspeakers. They were close to the floor because they were big. They needed to be big because they needed to be efficient. They needed to be efficient because we only had low power amplifiers, typically tube amplifiers. But looking back, there seems to be some kind of magic in how we used to listen to the speakers. What about bringing it up to date? Taking some of the concepts that we had in the old days and looking at them with fresh eyes, seeing what we can do to make it better. So let's think about efficiency. In order to be efficient and have bass, the loudspeaker has to be big. Hence the big cabinet and the big woofers. To get efficiency, we need low mass. We need high force from the motor system. But they have to be in balance. We have to get them in the right proportions to give us the frequency response and the performance level we want from the drive unit. And that's particularly difficult with the bass. It's easier to do with the mid-range. So let's talk about the mid-range first. And you can see here, it's a concentric mid-range. That should be no surprise given that I've got a preponderance of concentric drivers out in the marketplace, but they have their advantages. And in this case, we need large area to get the efficiency level we want. We want low mass and we want sufficiently high BL. So once again, I go to paper cone and 10-inch diameter, and it's a low mass thin paper cone with a small surround to avoid any added extra mass from the surround, with a 60mm voice coil so I can get enough force applied to that cone. And although it looks broadly similar to designs I've done before, there are some very specific differences that go into getting the performance I want out of this drive unit. The goal was, in terms of efficiency, that it should be 96, 97 dB sensitivity and go down into the 30 Hertz region and not require full boundary loading in order to get that bass level. So you could position it more conventionally as we've become used to when putting loudspeakers in our homes. But what is particularly different about this concentric driver is in looking backwards to how were the first loudspeakers developed, we didn't have very strong magnets in those days. And so we relied on field coils. We wound a coil of wire around a pole piece and connected to a battery to give us that fixed field against which the voice coil could react. As time went by and we developed more powerful magnets, First of all, alnico, and then ferrite, and then neodymium, which was a game changer. Neodymium being about 10 times the energy density of ferrite. We were able to develop smaller, lower cost magnets, and these days we're experimenting with all sorts of unusual arrangements to improve the performance that we get from those permanent magnets. And I say that because there are some factors that were introduced with permanent magnets that we didn't get from those original field coils. Could we relook at field coils? They haven't disappeared completely. There are some field coil drivers still on the market, new manufactured, but they typically are used with a full range loudspeaker driver, single cone, or maybe with a whizzer cone, lightweight paper, or with a compression driver, compression mid-range, horn-loaded, compression tweeter, horn-loaded. That's the majority of the use of field coils in the current market, but it's a very small percentage of the market. But I like concentric drivers, obviously. And so the thought came to me, could I do a field coil on a concentric driver? How is that done? And as I delved into this, I got the idea that by studying where the magnet paths go to direct the flux to the appropriate voice coils, not only could I have the voice coils concentric, but I had the field coils concentric. So basically I got a tweeter field coil wound around the center pole with a return magnetic path around that. Wound around the outside of that is the mid-range field coil, and outside of that is the return path. So it's a concentric field coil concentric driver. And I don't think that's ever been done before. But now I have. This is it. It's interesting when you have an idea that you want to pursue, in this case the concentric field coil idea, that sometimes you don't understand at the beginning the consequences of what you're asking for. And as I started developing this field coil, it was growing bigger and bigger and bigger because I need to get enough flux into both the 60mm voice coil gap for the mid-range and the 28mm voice coil gap for the tweeter. And doing that without all the parts fully saturating, which then means I need more power and more current. So gradually it grew to about 6-inch diameter. One afternoon I was just thinking, ooh, 6-inch diameter. I wonder how heavy this is. And I did a quick calculation because the density of copper and steel are within 10% of each other. So I thought, just imagine it's a block of steel, 6-inch diameter and nearly 6-inch deep. I got out my calculator and I go, that's going to be about 35 pounds just for the field coil motor on the back of this driver. That's a heavy drive unit. But the problem is, when we think of the construction of a drive unit, we've got a chassis and the magnet system is screwed to the back of the chassis, but it's supported on the rim of the front of the chassis. I didn't think I could support 37 pounds of magnet on the back of a chassis, even with a strong cast chassis. So inside the cabinet, I built a support structure to enable me to clamp the motor itself inside the cabinet, as well as screwing the chassis from the front. And so that dual support shares the load between the two and makes sure that it's much stronger and not prone to failure. We've discussed about what it takes to get efficiency level out of the mid-range. So let's look at what is required to get efficient bass. We said efficiency is low mass, high BL. It's also area. It's also cabinet volume. Now, clearly we've got a big cabinet. That was absolutely necessary. From the first calculations, it will set a limit on how efficient the base is and how low it can go at that efficiency level. But when you study it, you could say, okay, I've got a big cabinet, I'll have a very lightweight 8-inch driver and as big a magnet as I can put on it, and I'll have it efficient. Well, yes, but you won't have the right base alignment. It will be so overdamped that it has much less base than if you put less magnet or a heavier cone on it. You've got to have everything in balance. And so having set that parameter level that I wanted to achieve, 96 dB going down into the 30s, there's almost a unique combination of area and mass and motor strength that will give me the correct base alignment. And those parameters required an area that could only be satisfied by either a 15-inch base driver or, in this case, two 12-inch. And I chose to go for the twin 12-inch arrangement. 12-inch driver on the front and the other one directly behind it on the back of the cabinet. And additionally, to make it a vented box system. And the vents are placed on the back. 2 at the bottom, 2 at the top. So it gives you a chance to change tuning if you do want to put it closer to room boundaries by stuffing 1 or 2 of the vents. But now that gives me the performance I need of the efficiency and the base extension. But now I've got to engineer those drivers. And I still need lightweight. I needed about 50 or 60 grams moving mass for the combination of the cone and the coil. And that's not easy to achieve in a 12-inch driver. Once again, it requires paper cones, and in this case, a cloth-doped surround. But with that amount of area, I don't need it to move too far. So I was able to optimize the motor structure to give me the right BL in combination with the limited amount of movement that I would need in this arrangement. Now, the base drivers are not field coil. If I tried to do that, the size and the weight and the complexity gets enormous. So they are neodymium magnets, but dual opposing magnets in short coil, long gap motor structure. In fact, every coil motor structure in this speaker is short coil, long gap for maximized linearity, low distortion. Now, in terms of the front panel, it could have been just a flat veneered surface, but I wanted to give a bit more visual interest and use a curved baffle. Curved baffles are always good, or shaped baffles, at controlling the diffraction response of the tweeter in the mid-range. And so I thought, let's start with a curved cylindrical baffle. But how do you mount drivers into that and minimize the diffraction? At the same time, I realized that this cabinet is relatively short, and so the tweeter axis is below ear level. So in order to fire the tweeter towards the listener's ears, I have to either tilt the whole speaker backwards, put it on a short stand and tilt the whole speaker back, or I've got to somehow angle the concentric driver itself. And as I started to think about it, if you cut a angled slice through a cylindrical surface, the transition point becomes an ellipse. And I thought that could actually work nicely. It'll soften the transition point and give me that diffraction performance I want. And at the same time, I can emphasize visually that elliptical shape. In this particular design, I put this cover plate over the chassis, and the contours are designed to smooth the transition for the wavefront of the tweeter, across the cone, out onto the baffle, across the here, and into the curvature of that baffle. And this nice bright diamond finish edge highlights that performance feature. Now we have to deal with the bass driver. We have to cut a hole into cylindrical surface. And what that provides is, again, an elliptical cross-section at the transition point between the angle radius here and the curvature of the baffle. And so that visually matches with the elliptical shape of this section of the baffle. So it ties them both together. And interestingly, when you sat at normal height, you don't so much notice that surface. So it looks like a simple curve. And down here, you see that shape, which matches this shape. So I think they tie in very nicely. It's a floor standing cabinet. Does it go directly on the floor or does it go on a stand? We wanted to lift it up a little bit. It just looks a bit lighter given the size of the cabinet if it's on a short stand. And we looked at visual clues from furniture of the 50s, 60s, 70s and took a cue of the kind of legs that you get on credenzas. And so we made this solid walnut stand with the splayed legs that just gives it a bit of a lighter feel and matches the walnut veneered cabinet. And also picked up on the feature that was popular in those days of rounded corners. So this is a single piece of veneer. It's a single join at the bottom that goes across, up, all the way across, down and back underneath. So quite a good job of doing that veneering. Now the final aspect of the visual design, the industrial design of the speaker, is the grille. What do we do with the grille? Very often the grille is chosen to simplify the overall look of the speaker, hide the drivers, make it look more like furniture. So that was the driving force behind this. And there's always an issue between how much does the sound of the grille affect the performance, the transparency of the grille, the structure of the grille. And the answer is they always will affect the sound to a degree. In this case, we made the grille from a wooden structure with laminated, curved pieces of MDF and put a perf over that is custom perforated. So although from the front it looks very simple with the wood frame veneered, exactly the same veneers on the cabinet, when we turn it around we see the structure that holds the shape. This is a custom laser perforated sheet of acrylic with as larger holes and ratio of hole to solid surface area that we can get that is practical. And magnetically attached. So we simply offer it up to the cabinet and there we go. So now the cabinet looks more like a piece of furniture and certainly more like we would have had in the 50s, 60s, 70s. Is there an impact on performance? Yes. If you want to get the best out of the speaker, listen with the grills off. Can you listen with them on? Of course you can. But for absolute best results, take the grill off. Now let's see what we've got around the back of the loudspeaker. This finished prototype that is clearly not fully finished because there's no graphics on the back panel, but we'll get to that. Clearly the obvious thing is the bass driver, the other 12-inch bass driver, identical to the front driver, run in parallel, push to give enough motor strength and BL area to get the sensitivity to where we need. Below that, input terminals, we've got a pair for the woofer, we've got a pair for the MF-HF, the concentric field coil driver. They can be strapped together if you want to mono amp or mono wire, or separated for bi-amping and bi-wiring. Next to that is the additional input socket for the power for the field coil. We have an external power supply unit, one for each speaker. They can be put side by side in the rack, or they can be slipped underneath the speaker. And they supply the power for both the tweeter field coil and the mid-range field coil. And during manufacture, the voltage level or the current level that is supplied to the field coils is adjusted on test to make sure that the system sensitivity is set at the reference level. So the power supply will be matched to the individual loudspeaker. Now, to turn the system on, one way is we have this centrally mounted push button here, momentary action. So when you walk up to the speaker, lean over, push that button, and power will be applied to the field coil. If there's no music, after about 30 minutes, the power to the field coil will be turned off. That's to meet regulations, also minimize wasted power. They consume 50 or 60 watts for the pair of field coils together. There's also a momentary action push button switch on the front of each power supply. So if it's in the rack and it's more convenient for you to turn it on there, then you can do it there. Either way, it's your choice. Third way is there's music sensing. So as soon as you start playing music, it will sense that music signal and automatically turn on. But of course, there's potentially a little delay till it senses the music sufficiently. There are two switches, one either side of the power button. One adjusts mid-range sensitivity, the other adjusts tweeter sensitivity or level, plus or minus 1 dB steps for each one with respect to the nominal level that we set that matches the bass driver level. And we have 4 vents, 2 at the bottom, 2 at the top. Now, one of the reasons we do that is because we've got 50 or 60 watts being dissipated by the field coil. It allows some natural airflow circulation to help just take heat out of the inside of the cabinet. In addition, this plate, which behind it is mounted the crossover, also acts as a bit of a heat conductor so that any other warm air in the speaker can be radiated out. 4 vents allow for tuning to room loading. So if you get too close to the wall and you get too much bass buildup for your room or your room tastes, block up 1 pair of vents and it will tune it half an octave lower at reduced level, but compensating for the increased level from the wall, so they balance each other out but give you even more bass extension. We just caution you, don't block up a horizontal pair because then you'll block the natural airflow through the cabinet. So that's it. That's the back of the new loudspeaker. In my career, I've done lots of different types of speakers, different price points. The first speaker I did when I moved out to the US was a high efficiency speaker, 96 dB sensitivity. You know, that's unusually high in the regular speaker market, and easy to drive with tube amps because I made it deliberately easy to drive. And I find myself 30 odd years later coming back to the notion of high efficiency speakers with tube amps, thanks to this partnership with Jamie and Bill and forming this new company. So in a sense, I've gone full circle, and yet I'm achieving that in a whole different way to what I did the first time round.
So that is Troubadour, Andrew's new speaker for his new speaker company. Thank you so much for watching. If you enjoyed what you just saw, please consider subscribing to my channel. because I have another early exclusive look at Jones and Cerreta coming out on my channel very soon. I'm actually editing it right now. Thank you also to Andrew, Jamie, and Bill for being super cool guys to work with and for trusting me to join them in telling their story right from launch. It's a really big honor for me because I've never done that before, and I'm just so excited to be able to share this with you all. So you can hear Troubadour for its North American premiere this coming weekend at AXPONA 2026. Thank you so much. Bye.